Okay, so we'll get started now. If you can't hear me or if you have any issues, just let me know. I'm just going to change the layout a bit so the screen's a little bit bigger. All right, so thank you everyone for taking the time to come to this crash course on integration. So hopefully we are ready to do some maths. Make sure you have a notepad, pen and calculator, so you will be working through some problems together with me. So firstly, a bit of introduction about myself. I'm the co-founder of Pinnacle Coaching College, so I head the mathematics curriculum here, and I teach a lot of the mathematics classes here. So I can see a lot of Pinnacle students here as well. So those who are in my classes will know who I am. Those who are joining this type of course for the first time, welcome. Hopefully you will find it helpful. So I mainly specialize in teaching Extension 1 and Extension 2 maths, and I've helped a lot of students in the past to achieve great results. So hopefully you will find me sharing these experiences with you very helpful. All right, so let's go on. So what to expect today? So we will be looking at mainly integration. First part, we'll be looking at how to find an integral. And then after that, we'll be using integration to find area and volume. And we'll also take a look at some of the estimation rules, Simpson's rule and trapezoidal rule. Most of the questions I'll be using are typical exam questions. I may have made some small touches to it to make it a little bit more difficult, but it's typically how exam questions are set out. At the end, we will have a Q&A if you have any questions. And I think you can raise your hand at any point if you click on some buttons on the left, so you can have a play around with it. And if you have any questions or if you think I'm going too quickly, just give me a yell or just type message in the message box so I can see that I'm going too quickly. All right, so let's get started. So first of all, reviewing the very, very basic stuff, there are two main integrals that are in your reference sheet. So the first one will be the very basic one, which is x to some power. You add 1 to the power and then divide it by the same thing. And don't forget your plus c, the constant. And then there's a version which is with the linear function. Okay, so the most common mistake is actually forgetting it's only applicable to linear function to a power. So just be careful when you apply that. And then that's basically the formula. And if you do extension 1 as well, there is a reverse chain rule, which you can use sometimes. So there will be one of the questions I might show you guys how to use that as well. So you can see how it can be applied. All right, so we'll start by applying these rules just to see where we are at. So for example, the first one. Okay, so we'll do the first one together. So all you have to do really is take x squared. So you can do this with me if you like. So add 1 to the power. So add 1 to the power divided by the same thing. And then the 3, basically any constant, you just tack on an x and then plus c. Okay, so in other words, x cubed on 3 minus 3x plus c. So very simple. All right, any questions so far? Can everyone still hear me? I'm just double checking. Okay, great. So I can see one yes. I hope everybody else can still hear me. Okay, excellent. All right, good. So I shall continue then. So I'll get you guys to try questions 2, 3, and 4. Give it a go, and then we'll reveal the answer shortly. I'll give it a go. Okay, so I hope you all had a go with question 2. I'm just going to put up a poll just to see how everybody went. So did we think it was A or B? All right, so it looks like most people picked A, and that would be, let me check, I don't even remember. Yes, that would be the correct answer. Excellent. Okay, so if you didn't get A, you can have a look at the working here. So the first step will just be expanding this. So you get 9x minus 12 root x plus 4 and changing that root x to the power of a half. And then after that, it's just applying the standard integral rules. And when you add 1 to a half, it becomes 3 on 2. So you're dividing by 3 on 2, or effectively times by 2 on 3. And then the rest is just really simplifying, and x to the power of 3 on 2 is a 1.5. So how you can think about that is x to the power of 3 on 2 is x 1.5. So 1 plus a half. So x to the power of a half. So that's where that x root x came from. All right, good. So moving on. So next one, you have 2 choices again. I'll give you some time to attempt it. All right, so let's see how we went with this one. All right, is it A or B? All right, so I can see most people pick the first option, which is, I'm sorry, the second option, which is good, because that is the answer. So definite integral, so very standard stuff. Just integrate the different terms and then subbing the 2 into the terms and then subtract the second term with the -1. Just be careful with the power and how it affects the sign. And that's it. That's the only thing you have to be careful with. So the answer is 18. All right, if there are any questions at all, make sure you let me know. Otherwise, we'll keep going. So the next one, again, have a go and see which is the correct answer. Okay, so it's just come to my attention. There's a small typo. So it's meant to be a plus, not a minus here. Let me just fix that. So that one, just ignore it. Yeah, so plus. Okay, so I'm going to put up the poll now, see what everybody got. All right, that's great. Most people picked option 2, which is B. So that would be the correct answer, I believe. So here's the working. So the first step is to split that fraction first so that you can get little x's in the x's to the power. That's what you want to achieve here. So then simplifying all the powers, so it becomes -2 on the first one, and then it cancels out to 1 in the middle, x squared. And then you just apply the basic rule to all of the terms. Now with the first term, so you've got basically -5x to the power of -1. So in terms of simplifying, it's -5 times 1 on x. So just be careful with the 5, basically, so don't bring it downstairs with the x. Excellent to see. Let's move on. All right, so the next step, we're going to have a look at the linear functions to the power. So that's the other rule now. So let's have a look at this next set. All right, so I'll just quickly write down the rule here. So the rule was okay, so like that. Okay, so that's the rule we're applying in all 4 questions. So for example, the first one, very simple. You add 1 to the power, so it becomes 7, divided by the same thing, which is also a 7, times the coefficient of x, which is 7. Okay, so in other words, it's 1 on 49. Whoops. How do you clean this up? Anyways, you know what I mean. 1 plus 7x to the power 7 plus 6. Okay, so that's basically it. So go on and try the other questions, and I'll put up a poll shortly. All right, so the next one, here are the two options, A and B. Have a look at which answer you've got. I'm going to put up a poll just to see where everyone is at. All right, take your pick. Which one did you get? All right, so excellent to see overwhelming good response rate. Almost everyone picked the first option, which is good because that is the correct answer. So these are working very simple. So I add 1 to the power. So it becomes 5 divided by 5 times the -2 that's in front of the x. So that will be the most common mistake. All right, so next one. It's got two options again for you. See which one you can get. All right, so I'm going to hit the poll. Let's see. All right, so tell me, did you get A or B? All right, good. So I think it looks like most people got A. Excellent to see. So that would be the correct answer. So that would be the working. So the first step is actually just changing x plus 1 to x plus 1 to the power of a half. And then it's just about adding 1 to the power. So what's happening is add 1 to the power. Technically, you're dividing by 3 on 2 again times 1, which is the coefficient. So that's why it's times 2 on 3 in front when you flip it. And then you just put the numbers in, take the difference, and that's it. All right, good. Next. All right, so I'm going to put up the poll now. You had a chance to have a go. All right, tell me which one you get. All right, excellent. So I can see there's a bit of a split here in terms of the correct answer. So let's have a look. So in this one, the first step is to change it to the power of -1/2. And then when you add 1 to that, it becomes a half. So you have a half on the bottom as well. So that's the n plus 1 component. And then the A is the 2. So those people who didn't multiply the 2 may have got the wrong answer. So you should only end up with 1 plus 2x to the power of a half, which is that answer there. All right, so now we've reviewed the basic stuff. Let's have a look at some interesting exam questions. All right, so this one is an exam question I sort of picked up from one of the assessments. Let's see what you guys think is the correct answer. All right, so I'm going to put up a poll just to see what everyone got for this one. Okay, so it looks like the overwhelming majority went for option 2, which is B. I think there's also a couple who got D. Let's have a look. All right, so the trick here for this one is you're not meant to integrate this. So those who attempt to integrate this, you would have went down the wrong path. This is actually a semicircle of radius 2. So what you're really doing is using your understanding of a semicircle to get to the integral. So it would have been pi r squared on 2, half of a circle, so pi 2 squared on 2. So 2 pi would have been your answer. So that would have been B. Okay, so if you forgot a half it, you might pick D, and I'm not sure why we pick A or C, but who knows. The other very common question, just so that everyone knows, is like, for example, it could be something like this, where there is an absolute value in the integral. And most students get stumped by this. They're like, how do you integrate something with absolute value in it? Well, the point is you're not meant to integrate it. You go and study the graph and look at the area, which is just going to be, if you sort of think about it, it's going to be areas of triangles. Okay, so you can just draw and work it out quickly. So that's my little tip. Moving on. All right, so this is another one, just playing around with the area you see on the graph. This is actually based on a HSC question. See if you can figure out what the correct answer is. All right, so I'm going to put up the poll now just to see what everyone got. All right, so I can see there's an overwhelming majority for B, which would be the correct answer. So very well done to those who got it. So this is actually not as hard as it seems. So the question goes, you want to evaluate the integral from minus A to A. So just imagine minus A to A, such that it becomes 0. So in other words, you want the area on top to completely offset the area on the bottom. So with that in mind, you can pretty much ignore these two areas because they exactly offset each other. Same with these two. Okay, so you can ignore them. So you're just really focusing on these 3 blocks. So if you think about it, they are, so this one's a 1 by 2 units. There's 2 units, 2 units, 2 units. So in other words, you need exactly 6 units worth, yeah, so that you're completely offsetting the 6 units worth. So in other words, you need 3 units each, so to speak. Okay, or in other words, you want a minus 3, which is this distance here, a minus 3, times 2. So the height of this to equal to 3. That's what you want. So a minus 3 is equals to 3 on 2. So a is equals to 3 plus 3 on 2, or 4.5. So that's where that came from. So hopefully that clarifies it for those who didn't quite get it. All right, so moving on, any questions so far? So if you're not aware, you can type chat in the chat box on the left. I'm still checking that every now and then. So if there are any questions at all, you can't hear me or anything, just let me know there. All right, so if there are no questions, I'll move on. All right, so this is the last question we're going to do on just pure integration before we look at the application, which is the volume and area stuff. So this type of question is a harder logic where you have to use the differentiation to help you do the integration. So I'll let everyone try the first part, which is basic differentiation. So remember, you will need to use the chain rule on that. So you will need to treat that as 9 minus x squared to the power of a half, and then differentiate that. So I'll let everyone have a chance to differentiate it first, and we'll discuss how to do the second part. Okay, so let's take a look. So first, obviously you change it to the power of a half, and it's just a chain rule here. So bring the power down, subtract the power by 1, multiply by the derivative of the inside, which is just minus 2x. So just sort of cancel that out, the 2.5. So you're left with minus x. So minus x on, so just changing that back into a fraction, you get the next line. All right, so if you recall the logic on these type of questions, let me see if I can clean this up a bit. Okay. There we go. All right. So the logic here is, if I have 9 minus x squared, and I know the derivative gives me minus x on square root 9 minus x squared, then ideally, if you have that in your integral, you'll be able to take it back. So you're using this logic to make adjustment to the integral in the second part. So in particular, you want to make your integral actually looks like the derivative from the first part. So I would take out the 6 first. Okay, and then let me see if I can pick another color. There we go. So you need a minus. So I'll put in a minus and a minus outside to sort of offset the adjustment. So see if you can take it from there and use the integral logic to take it back to what it was before. All right, so here are some options. Now that you had a go, I'm going to put up the poll very shortly. So have a look at the answer, see which one corresponds with your answer. All right, so tell me, which one did you get? All right, good. So I can see that most people pick B, which would be the correct answer. So here's the working. So I already did those steps for you pretty much. So then from there, it's just a matter of, okay, because we know that, just reminding you guys, we know that if you have this as your integral, you can take it back to that. And that's pretty much it. So that became the square root of 9 minus x squared. That's it. Okay, just simply replacing it. Now, for those who do extension as well, you can do this question using the reverse chain rule. So we'll take a look at that in the next slide. So this is just repeating the same question without the derivative component. So the reverse chain rule, for those who missed the first couple of slides, is literally if you have a function to a power, it needs to come with its derivative. And then you basically reverse the chain rule by adding 1 back to the power and then dividing that by the same thing. So if you look at the question here, the first component needs to match up with f dash x, and the second component is basically your function to the power. So if you check what f dash x is, it should be minus 2x. So that's actually what's happening in this step. So if you take the 6 outside, that looks terrible. Hold on. So yeah, if you take the 6 outside, so the 6 is out and you need a minus 2, so you put the minus 2 in, but have a minus 2 outside as an adjustment in the denominator. So the idea is when you multiply back in, you should get back the question, which is 6x. Then it's just applying this formula here. So you can see f dash x, fx to the power of minus a half, becomes add 1 to the power, which is a half, and then divided by the same thing. And then you get to exactly the same thing. All right, so that's for the extension students in the room if they want to know how to apply the reverse chain rule. That's it. The next section will focus more on the application, so areas and volumes. We'll start with a baby one in the next slide. Let's have a look. All right, so in this question, we've got two graphs. We've got a parabola and we've got a straight line, y equals 2x. We know that it intersects at 0 and a. Let's actually all find the coordinates of a first. So simultaneous equations, I'll give you a minute to find out the coordinates of a. Once you've done that, you can actually go on and do the integration as well. Here. Or even if you unplug, can you like can you hear me? Okay. All right, so I'm pretty sure we don't have much problems solving simultaneous equations. So let's have a look. So equation 1, equation 2, sub 1 into 2. So then it becomes 2x is that. Move everything to one side, so move everything to the left side. So factorize 0 or 4. So if you go back to the diagram, 0 obviously relates to the origin. You're really looking at 4. All right, so now the question, just be careful, is after the coordinates. So make sure you're answering the question. Coordinates is x and y. So just sub x equals 4 back into either equation 1 or equation 2. So equation 1 is easier. So it's just 4 times 2, 8. So that's the coordinate. All right, so now we've got the coordinates. The next step is to do the integration. So just going back to the question here. So it's telling you that this is for 8. So it's telling you what the upper bound is going to be in your integral. So remember, when you build the integral of an area between two functions, you basically want the top function and then you minus the bottom function. Okay, so think about what your top function here is and the bottom function here is, and then find the integral from there. So I'll give you another minute to work that out. I think a couple of people must have trouble logging in. Okay, so I've got two options for you, either 32 on 3 or 128 on 3. So let's put up the poll and see what everyone got. 32 on 3 or 128 on 3. All right, excellent. So I think it looks like everyone who answered picked A, which is good. Gives me great confidence. We can do a basic integration. So let's have a look at the working. Very simple. So the top function is the parabola and the bottom function is 2x. Simplify the algebra a bit and then do the integration. And then it's just a matter of then subbing the numbers in there. So 4 goes in first and then 0. Everything's going to be 0 on the second part and then put that into the calculator. All right, good. So let's take a look at the next one. So this is an example where we are looking for the area with respect to the y-axis this time. So remember, how do you find the area with respect to the y-axis? You have to integrate boundaries that are y values. So think, what are the y values here? Your function should be in terms of y. Think about what that means, and you should be integrating with respect to y. So I'll give you another minute to have a go. Okay, so I've got two options here for you. 1648 or 12 units square. So that just let me put up the poll and see where everyone's at. Okay, good. So I can see an overwhelming majority pick the second one, which is good because that would be the correct answer. All right, so for those who didn't get to the correct answer, the key point is first you have to take the equation and then you need to make X the subject. So moving the 1 to the other side and then cube rooting that or turning that into an indices form. So that's actually meant to be a third. Okay, so the boundaries would be 1 to 9. So add 1 to the power becomes 4 on 3, and then divided by the same power would be the reciprocal, which is 3 on 4. So talking about it, that's what I meant. So 4 on 3 times 1. Okay, so then that becomes taking the reciprocal 3 on 4. So that's where that next line came from. And then it's just a matter of putting in the numbers and you should get 12. All right, so moving along. Next one. This one's getting a little bit more tricky. We've got two graphs, that intersects at two different points. And we're looking to basically find the area bound by the two graphs. So the first step, we need to find out where they all intersect. So I'll give you guys a minute to solve it simultaneously, see if you can find out where they intersect. Okay, so let's have a look. It should be pretty simple. So you sub y equals 2x into the cubic and then move everything to one side. X is a common factor. Take it out, factorize it further, and that's it. So 0 to 1. So obviously, if you go back to the diagram, 0 is the origin, 2 and 1. So A is probably 1 and B is 2. Now, if you look at the question, it goes, you're just really showing the x coordinate, so you don't need to go and find the y coordinate. So you just conclude and answer the question. So x is 1 and 2. All right, so now we've basically got the boundaries, so we can set up the integral. So you're using the integral that relates to the area between two graphs. So you're looking at top graph minus bottom graph. All right, I'll give you a couple of minutes to attempt this. All right, so I'm just going to put up the poll and check everyone's progress. If you've got the answer, just go ahead and pick the answer. All right, so I think I'll stop here. I can see the overwhelming majority picked the first option, which is good. Okay, so let's have a look how we do this question. So I've just split it into two parts because obviously you can see the relationship is a little bit different depending on whether you're talking about from 0 to A or A to B. For 0 to A, the top graph is the cubic. So you can see the cubic went first, followed by the straight line in building the integral, and from 0 to 1. Okay, so simplifying the algebra on that, doing the integration, then just sort of simplifying a little bit more, put in the numbers, you should get a quarter. Okay, so once you get the first part, then you sort of repeat the same thing for the second part, which is the reverse. You can see the straight lines on top this time, whereas the cubic is on the bottom. So straight line goes first, then followed by cubic. And then again, simplifying, the only difference between A1 and A2 you see how this is x cubed minus 3x squared plus 2x. And this one's minus x cubed plus 3x squared minus 2x. So the sign is just flipped. Okay, so the integration should be exactly the same from here. Sub in the numbers, you should get, oh, that's a 4, not a 9. So minus a quarter, minus a quarter, which is also a quarter. So adding the two up, so you should get a half. So very well done to those who managed to get to the answer. So this one's a little bit more tricky, having to split the integral into two different parts. All right, so let's take a look at the next one. I think the next one, it's a more challenging one. Oh no, this is, no, it's just a volume question. Hold on, not yet, not the challenging one yet. All right, so let's keep going. So let's take a look at volume questions. So we're going to look at rotation about x and y axis. So in the first instance, the x axis, for those who've forgotten the formula, here it is. Y squared dx. Okay, so you need to make sure you square your function. And then you're integrating with respect to x because we're rotating around the x-axis. So I'll give you a couple of minutes to attempt that. Okay, so I'm just going to quickly put up the poll to check everyone's progress. So A was 324 pi, B was 162 pi. So for those who missed the answer, if you can't see the slide, A is 324 pi, B is 162 pi. Okay, it looks like the overwhelming majority is for A. That's great. Good to see everyone's on top of their game today. So it will be the first one, 324 pi. All right, so this one's also based on a HSC question, actually. This one's very similar to one from last year. Let's take a look. So first, you need to square the function. So if you square this function, you end up with 81 minus x squared. Okay, so once you've done that, it's just a matter of performing integration on that. So you get this thing, 81x minus 9x cubed on 3, simplifying that, and then just subbing in the numbers, and then putting in the minus 3 as well. Now, another little trick you can use here is, I mean, if you look at this function here, 81 minus x squared, it's an even function, okay? So you can also use the fact in even functions, you can go 2 times from 0 to 3, 81 minus 9x squared. So this way, you see how you get this ugly number on the second bit, the 81 minus 3, and then with the minus 3 substituted, I mean, it ends up being the same number, you can see, because it's an even function at the end of the day. That's what it means. But that will just, yeah, makes it a little bit easier to work with. It's going to go to 0 if you go for the 2 times approach. All right, so moving on. Next one. This is a rotation around the y-axis. So y-axis formula looks like this. You need to do x squared this time with dy with respect to y. Give it a go. See if you can get to the correct answer. Now, for those who have no idea where to start, this is actually quite a step up from the previous question. Now, if you think about how this one rotates, so actually I'll go to the next slide with all the answers first. So those who's got an answer, you can start picking from the list. But those who have no clue, now think about how this one will rotate. So you've got the straight line that will rotate, yeah? So if you think about what a straight line would do, you'll basically get a cylindrical shape, okay? Then you take away the rotation of the graph itself around the y-axis. Yeah, so it's basically a difference between two volumes here, or subtraction between the two volumes here. You can't just simply go take the area like what we'll do in the previous part. You have to work out the volume of the independent shapes and just subtract it through. Okay, so the formula is probably more relevant for the second part when you try to do the integration relating to y equals root x. Yeah, so you remember you want to integrate with respect to y, so do x squared dy. This one, you can also use the same formula, or you can just simply use the volume formula of a cylinder. So pi r squared h can also do the trick. All right, so that's how you will approach this question. If you don't know where to start, you see if these two sort of point you in the right direction. All right, so I'm going to put up the poll now so I can gauge where everyone's at, just to see whether we've got a clue or we're a little bit lost. It's very hard for me to tell when not interacting with everyone in the classroom, so I'm trying to guess my way through here. All right, so yeah, if you've got another pick. Okay, so I'll just end the poll now. So I can see there's a good balance between C, B, and C. Majority still went for C, followed by B. So C is actually the correct answer here, and I think those who did B just probably did the second part, but didn't subtract it from the first part. So let's have a look. So as I mentioned before, you can treat that as a cylinder minus the rotation of the curve. So the cylinder, the radius is basically this distance here, right? So from 0 to 3. So the radius is 3, and the height of this is the y value, which is root 3. So you just use pi r squared h and you'll get the first chunk. The second chunk, this is where you have to do a bit of rearrangement because you need to turn it into x squared. So if y is equal to root x, then root x is y, square that, and then x squared that will be y to the power 4. So that's what you end up integrating, which is a very simple integral to do. Putting in the numbers and then do the subtraction, you'll get the 36 root 3 on 5 pi. All right, so hopefully that makes sense for those who didn't quite get there. This is a little bit more challenging, especially when you try to rotate an area sort of between two things around certain axes. You have to sort of try to visualize what volume, are you trying to calculate. All right, so moving along, what have I got next? Next one is the challenging one I've got. All right, so this is an example of quite a tough question for calculating volume. So for those who want a bit of challenge, this is probably the one I'm going to tease you out a bit. So we've basically got a parabola here. Looks very simple. We are trying to do the rotation around the y-axis. So as mentioned before, you are just simply applying this formula, x squared dy. So I might give everyone just 2 minutes to have a go at building it, and then you'll probably realize why this one is kind of difficult. Okay, so I suspect we are starting to get stuck. I guess the main issue here for those who actually have a go is you actually will struggle to just try to make x the subject. Okay, so no, it's not, you're not just trying to make x squared the subject. So something like this, so for example, like that, that's not good because you still have an x in here. Yeah, that's a problem because you need it in terms of y, and that's why this one's a little bit tough. So let's have a look. So the first step, how do you make x the subject? That's the struggle everyone would have went through. With a parabola, the easiest way is to try to complete the square. All right, so what I did here is I moved the 8 across, so it's y minus 8, and then try to complete the square, so half of 6, which is 3, add 3, square to both sides. So on the left side, it just becomes 9 minus 8, which is 1. And then the perfect square on the right. So square root that, plus or minus square root of y plus 1, and then move the 3 back across. So that's it. Now, so for those who are familiar with how the parabola works, the x is equals to 3 plus square root y plus 1 relates to the right half of the parabola, and the 3 minus relates to the left half of the parabola. Okay, so use your understanding to try to build the integral. Now x is the subject. It should be a lot easier to manipulate. And don't forget, you still need to square it when you're building the integral. So I'll give you another couple of minutes to attempt that, and then we'll go through the answers. Okay, so I'm just going to put up the next slide, which has all the options, so you can check against the options. And I'll put up a poll in a minute just to see what everyone got. Okay, so I'm going to put up a poll now just to see where everyone is at. Actually, before I put up the poll, just to make sure everyone's on the right track here. So your boundary should be, you're rotating around the y-axis, so y boundaries. And you need to square, so x squared dy. So you will need to square this thing. Okay, if that's not what you've done, have a go at attempting that integral now and see if you can get to the answer. All right, so I've put up the poll now. If you've got the answer, take your pick. Okay, so I'm just going to stop the poll there because I think there might be some issues with the answer, so let's have a look. Right, so let me just close that. All right, so I'm going to just switch to a board and just do it together with you. All right. So starting with the fact we're going from 0 to 8. All right, so that's what we are integrating. So expanding that out, so square the first one. That's not what I want. Hold on, clean that up. There we go. So 2 times 3. Okay, so that's just a straightforward expansion. And then from here, just cleaning up the expression. And then just adding things up together. All right, so now the integration. So 10y. Y square on 2. And with this one, add 1 to the power. And then divided by the same thing, which is times the reciprocal. And then from here, it's just a matter of putting things into the calculator. Now the second chunk is mostly 0, but just be careful, the last term is not going to be 0. It's going to be, let me write that up, times 1. Okay, so just putting that into the calculator. All right, so you should get 8 pi on that one. Just write that up, unit cube. All right, so yeah, hopefully that explains this question. So if there are any questions, just put your hands up and let me know. Otherwise, I can also answer it at the end of the class. So moving on. So we'll ignore the next slide because I noticed there are some issues with the answers. Hold on. Okay. All right, so that's pretty much it. That's a very difficult volume question just now. And it sort of pushes you to think about a different technique where to try to make X the subject, you need to complete the square. Another option, if completing the square is not something is natural to you, just going back to the previous question, what you can also do is treat that X as a quadratic and put it into the quadratic formula. So what I mean is, if you sort of take this equation and then move the y across. So A is 1, B is -6, and C is 8 minus y. So you can also do that and apply the quadratic formula. So it will look something like this. So x is equal to minus b, so 6, plus or minus b squared, so 36 minus 4ac. Over 2a. So you can sort of do that sort of simplification as well if completing the square is not your thing. So just letting everyone know that. All right, so finally, the last section, not a hard thing to do, trapezoidal rule and Simpson's rule, but often misapplied all the time. So especially when there are so many methods floating around for both rules, you have to have some clarity around which one you're going to stick with and which one you're going to use every single time to get to the correct answer. So we'll use this as an example to attempt both the trapezoidal rule and the Simpson's rule. So we'll start with the trapezoidal rule first. Now, the thing with trapezoidal rule, or both of these rules, is now on the reference sheet. So I'm going to focus on applying the version in the reference sheet because I don't want to avoid any confusion, especially when under exam pressure, you might remember something incorrectly or things like that. Just stick with the version in the reference sheet. I mean, I can show you the multiple application formula as well, but I'll let you have a go first, and then we'll take a peek on the answer. All right, so I'm going to put up the poll now just to see what everyone got. Okay, so I can see a lot of people went for option A. So let's have a look. So yep, the answer would be A. So if you stick to your guns and apply the trapezoidal rule in the reference sheet, so the B minus A, so I just have the table here. So B minus A, you're talking about one application, okay? So the first interval will be 4 minus 0 on 2, and then you just add the two values together. So if you have to do a slow and steady and just do 2 applications, 3 applications, 4 applications. It's a little bit long, but at the same time, you don't have to remember a formula and you just have to stick to whatever's in the reference sheet. So that should get you 15.8. Otherwise, I've got the multiple application formula here. So basically, those who understand the multiple application formula, you just have to basically double everything in the middle. So you double all the values, 0.8, 1.5, 1.3, because if you look at it, those are the numbers that gets repeated in the single application formula. Okay, so that's why you double those guys, and then it's just a matter of adding them together. And the first one is just still sort of like a H on 2 situation, where H is the value of one interval on 2. Okay, so it should get you to the same answer faster way, but if you're not confident applying a multiple application, stick to the single application. All right, moving on, Simpson's rule. So Simpson's rule, a little bit different. It's got 3 values this time for one application. So when you apply it once, it's 3 values in one go. Okay, so if you're using the single application, there should be 2 times. So I'll give you a couple of minutes to have a go at doing that. So I'm putting up a poll just to see where we're at. Okay, so it seems like we are a little bit slow to respond because I'm covering up the questions. I'm just going to close it now and then just give everyone an opportunity to attempt it first. Okay, so I'm going to put up the poll again just to see if we got to the answer. All right, so the response rate is a lot better this time. I think clearly I was jumping the gun a little bit. Okay, so I think it looks like most people got B as the answer. That's excellent to see. So this would be the application. So I've just done 2 applications of the single application formula. So be careful with the B on A. So the B minus A is, if you go back to the table, it's across 3 values. So it's 8 minus 0 and then 16 minus 8 if you like. So on 6, that's the formula in the reference sheet. Some of you might have seen the H on 3 formula. If you're doing the H on 3, it's just 1 interval. H on 3, if you go back to the table, H would be 4 as opposed to 8. So just be careful of the inconsistency here. All right, so it's just 1 for 1 in terms of application. So 1 for 1. And then 1 for 1 again, and then just putting that all together into the calculator. All right, so last one on Simpson's rule. Have a read of the question. This type is probably one of the harder types where you have to extract and observe the values from the diagram itself. I'll give you guys a couple of minutes to attempt that, see if you can get to the answer. Okay, I'm just gonna throw up the poll now just to see where we are at. Okay, so I might just end the poll there. Looks like everyone had a good go at it. Majority picked the second option, which is great. So let's have a look. So the hardest part about this one is there's no values. You have to observe it yourself. And I think the hardest one is these end values. What are they? Well, because you can't see any distances in there, they're basically zero. So if you were to measure the distance at those points, it's just zero, okay? So if you see a diagram like that, where you feel like, oh, I don't see a number for a point where I expect to see a number, is probably zero. The other three bits is just the other three things you see. So it's basically 1, 2, 3, 4. Sort of 4 sections here, so you have 5 function values, and if you sort of split the 100 across, you're going up 25 at a time. So one application is B minus A, so 50 minus 0 on 6, 1 for 1, 1 for 1, and then you repeat the application, pretty much the same value on the second application, so again 1 for 1. Okay, put that into the calculator, you'll get to the answer. And that is it. So hopefully this little crash course has given you a bit of an exposure across the different types of questions that can come up, and I sort of point out all the different potholes and tricky questions that you can come across in this area. Generally speaking, integration is not a very difficult topic. You just have to be careful with your numbers. Double check everything, make sure you're putting in to the calculator correctly. I've seen a lot of calculator errors in this area. And that's pretty much it. I wish you best of luck with your assessment. You're now Masters of Integration. So hopefully you're feeling a little bit more confident now. I'll open up to the room to have a bit of a Q&A. If you do have any questions, feel free to raise your hand. I think you can just raise your hand. Otherwise, just you can exit anytime. And for my students, I'll see you all in the new week. So yeah, if you have any questions,